All right. Well, happy Friday, everybody. It's week 3 Friday. We're about a third of our way through the quarter. Just a little bit more. I don't know. Okay. You know. Okay. Today we're talking chapter 7, and thus far in our class, we've been doing a lot of stuff in R. Okay, R is our tool. Okay, the tool that we use for data analysis, kind of the foundation. In order to kind of ask questions and answer them, we need tools. Okay, I don't want you to think that this is an R programming course. Okay, it's not. It is not an R programming class. It is an introduction to data science. But think of it like I don't know. Did you ever take like wood shop in high school or even maybe middle school or something? Okay, what'd you do during like the first half of your course? It was all like safety, right? It was all like don't cut yourself with the tools, and like this is how you use the tools, and this is how you use the tools safely. And then once you learned that, or maybe you had like these kind of little things, then you could start thinking about crafting something neat, right? Like maybe a spice rack or something, right? This is, and similarly in our class, these first few weeks, it feels like all we're doing is stuff in R, okay? And that's true. We got to learn the tools. Thankfully, it's not like you can really hurt yourself with this. You can certainly make mistakes and certainly run into errors and things like that, but we've got to learn the tools first. And then once we establish the usage of the tools, then we can start talking about the ideas really into that we bring in when we do data analysis and data science. Okay, so today we still have to cover tools. Okay, we still got to cover some tools, and then probably sometime next week, and we can start introducing at least basic ideas. And we're going to start off. We're going to start off with ethics. Just like when you do data analysis and data science, what are some of these things that we got to think about? How do we use this data ethically and stuff like that? Okay, but anyway, we're still in the tools part, and today, I was debating whether I should just kind of do things like some live coding here, or present some slides, and kind of went back and forth. I decided to go with this. I've posted this draft file. This is a draft file, and I'm going to be adding to it on as we go along. And if you want to follow along on a laptop, that's fine. If you don't want to, if you just want to sit back and watch as I talk about it, also totally great. And I'm really just kind of following what's been written in our textbook from chapter 7. Okay. And so chapter 7 is all about iteration, okay? So what is iteration? Iteration is the idea of repeating the same task, just slightly differently, and doing it again and again and again, okay? So you're basically doing the same task, but just ever so slightly differently, and you do it again, right? It's kind of like if you had to make sandwiches for like 20 people, okay? You basically you get instructions, you make a sandwich, you go on to the next one, make a sandwich, so on and so forth. And we're going to be doing stuff like that, okay? R has a few ways for us to do this, okay? So first I'm going to load up our libraries, okay? Actually, I already have the tidyverse loaded. Modern data science with R, the Lawman library, which contains a bunch of baseball data, okay? And what we're going to do is we're going to take a look at the team's data. Okay? Now, we can ask for what are the names that exist in the team's data, and then we can also ask for help. You can also ask for help on teams, which is what I already have it posted here. Okay, but help on teams shows up here, and it kind of gives us the definitions of each of these variables, each of these variables, right? Okay, now the names, they all show up right here. It's not, again, if you're familiar with baseball, then these abbreviations mean stuff to you. But if you're not, then maybe they don't mean anything, and you got to go to the help, right? So you can see strikeouts by batters, stolen bases, caught stealing, things like that. And even these things, depending on how familiar you are with baseball, may or may not mean anything to you, right? Like, what is the idea of a stolen base? You've like heard of it, but what is that, right? I enjoy baseball, go Dodgers, but I don't feel like explaining all of this stuff here, okay? But these are all different things, and again, if you're a fan of baseball and you've attended a few games, somebody might have explained a bunch of these things. Maybe you learned this as a kid. Maybe you're an adult and you have no idea what any of these things mean, and that's totally fine, right? Like a sacrifice fly. These are all kinds of like a sacrifice fly is actually, it's a good thing. It's a good thing, okay? But even though it results in an out. Okay, so anyway, you might not even have an idea. Like, so we're talking about the team. So what is each row in this database? The teams. Each row. Like, what would be a typical number? Do we have any baseball fans in this room? No one in this room is a baseball fan. Oh, man. This is, like, completely lost. Okay. All right. So each row, so I might ask, like, what would be a typical number for this, right? And this is kind of like, this is the G. What is the G anyway? G is number of games. Okay, the number of games. So what would be a typical number? Okay, well, what we should see, okay, well, if you're not quite sure, you can do STR or glimpse. These are both basically the same thing. STR, structure, is what comes in base R, okay? And then glimpse is something done by the tidyverse, and you can see kind of the output of both of these things, right? So this is just kind of like, as you're exploring your data, right, you can do, so one thing you can do is view. We can always type in capital V, view. And I'm a big fan of view. Okay, whoops. Okay, and so view pulls it up here. And, okay, well, in 1871, that's what it looks like. But, like, if I just sort. So what we should be seeing, okay, for G, the typical number is 162, okay? In a typical baseball season, every team will play 162 games, generally, okay? That's what's happening during the regular season, okay? So each row represents 1 year, 1 season, and then a team, okay? A team. And so one row will be like the 2019 Los Angeles Dodgers. And there will be another row for the 2018 Los Angeles Dodgers. And another row for the 2017 Los Angeles Dodgers, right? So you think of every season, each year, there's a season, and there's a team. There's 30 baseball teams in Major League Baseball. And so every year, we would expect to see 30 of these things, okay? And then typically, there's 162 games. Sometimes a game gets canceled, so that this team only played 161, okay? And what happened here? Why are there only 60? COVID, right? Pandemic. So they had to cancel a large portion of the season was canceled. They did manage to play 60 games, and the Dodgers won the World Series in 2020, okay? And we'll see what happens this year, okay? But anyway, That's what you have. You have glimpse. So rather than having to look at the thing, you can also kind of see this, and this will tell you what type. So right at the beginning, it tells you what type of variable you have. You got integers, factors, characters, things like that. Okay. But anyway, there are a whole bunch of these variables. Okay, a lot of these numeric variables, things like runs against and hits and stuff like that. And what if we wanted to get the average for a bunch of these things? Okay, now we could do this. We could do this ourselves. We could say, you know, what is we could take we can ask for mean. Are you guys able to see this? Or maybe, okay, I'm going to say mean of teams, $sign. Let's do mean number of home runs, okay? And that number is 104.92, okay? So during the entire season, on average, the mean number of home runs is something like 104, okay? And the median is 109, right? And I think in your homework, you looked at players that had 50 home runs or more in a single season. 50 home runs or more, which is a big deal considering the entire team over one entire season on average gets something around 108, 109. And so if one player gets 50 home runs, that's like half of what an entire team is expected to achieve an entire season. So anyway, this is what we have, okay? Now what we can do, you've got a question.
Yeah, so what does $sign mean?
$sign means extract that variable, okay? So teams $sign HR would be extract that variable.
Is that like the summarize?
Huh?
Is that like the summarize stuff?
Well, here I'm just asking for the mean or the median. So I am asking for a summary, but I'm not using dplyr. Okay?
Oh, right.
Like if I wanted to use dplyr, I could do teams, and I could do summarize, and then I could say mean HR is equal to mean of HR, okay? And then I would get the same number here, okay? But it would, but I think it's easier just to say, hey, take the teams table, let's just look at the home run column and get the mean, okay? So that's something we can do, right? Now, it's not, if we look at this, we might want to start with, we might want to get the mean of all of these different values, okay? Runs, at-bats, hits, second base, third base, doubles, triples, I should say, home runs, base on balls, things like that. These are all different numeric values, and we want to see, okay, what kind of values do we get? And so we could, it would be a pain, but we could do, okay, mean, teams, $sign HR, runs, okay? Okay, and then we could say mean, teams, $sign AB, all right? And we can go through all of this and keep having to repeat ourselves every single time, okay? And some of these things are going to have NAs, so for a lot of these things, we might have to do NA.RM equals true, okay, to get the numbers. Some of these things don't have NAs, but let me see which one might have some NAs. In recent years, no NAs, but we might have to do something like that, okay? Now, rather than having to go through and typing mean, teams, $sign run, $sign AB for every single one, we could write a loop. We can write a loop, okay? And so this is the structure of a basic loop. This is called a for loop. And a loop basically says, hey, do this thing and do it a bunch of times. Okay? So what I'm going to do is, notice there's a few ways I can do this, right? I can do teams $R, teams $AB. We learned how to select one column using a numeric index. Do you guys remember how to do that? Using square brackets. So I could ask, what's the mean of teams $runs? Okay. Or I could ask the mean of teams, single square bracket, runs is the, I believe, the 15th column. Okay. So I could do teams, comma 15, right? So I could say select the 15th column and give me this thing. I can also say, all right, what is mean of teams, the 16th column, okay? And I get that, so on and so forth. So what we're going to do is we're going to take that thing and we're going to say, hey, make a for loop. Start at the number 15 and basically do this thing starting at the number 15 and go to 16, go to 17, go to 18. Keep doing this until you get to 40. Okay? Dot, dot, dot. Keep going until you get to 40. That's what this means. For I in 15 through 40. For I in 15 through 40. Now, what we have to do when we run a loop is we have to store the calculation result somewhere. Okay? So we're basically saying, for every value, I 15 through 40, calculate mean of teams, comma I, the 15th, 16th, 17th, the ith column, whatever that is. Ignore any missing values. So we're going to say na.rm is true. Okay? And then, so what's happening? What is this? This says save it. And what does this thing mean? Save averages I minus 14. So what's going on there? So I start off with averages null, okay? So if I say, what is averages? It's nothing. But what I can do is I can store it into, say, position 1. I can store the value, say, 100. And what is averages now? Averages is 100. I could say store into position 2, store the value 220. Okay? And then I could even say store in position 5 the value 555. Okay? So do you guys see these commands? Averages, the square bracket 1, square bracket 2, square bracket 5. Averages is what we call a vector. And we are just saying, hey, put these values into these positions. Put 100 into the first position, 220 in the second position, 555 into the fifth position. Okay? And it says, oh, you want 555 in the fifth position? I don't even have a third and fourth position filled out yet. But if you want it in the fifth position, I've got to kind of create a third and fourth value spot. There's no values there, so it puts in an NA. Puts in an NA. Okay, so tell me, what is this loop doing? So it says for I in 15 through 40, it says start I at 15, keep counting up, 15, 16, 17, keep going until you get to 40. And then what? For each thing, take the ith column, the 15th column, 16th column, calculate the mean, and store it where? In I minus 14. It's going to store it in averages in position. For the first value, we're going to store it in position 1. And then the last value will be stored in position 26. Okay? So this I minus 14 is just kind of an offset. Because I could just say stored in position I, but then I'm going to have what? I'm going to have 14 NAs in the beginning. And then we'll get all of the values. It's fine. Go ahead. But so let's go ahead and run this. So start off with, let me clear this out. So we've got averages is null. Then I'm going to say for I in 15 through 40, store it all in there. Okay, now let's go ahead and just check out what averages is. All right, so I got a bunch of numbers. This is the average of the 15th column, average of the 16th column, average of the 17th column, average of the 18th column, so on and so forth. Now this is not super helpful right now, okay? What would be helpful is if we had the names, right? So let's take a look at the names in the teams column, okay? These are all the names, and what we want is we can say, oh, this was the 15th one. 680 is R. 5,126 is AB, at bats. 1339 is the next one, H, for hints, okay? We want to put all of those. So we want all of the values from 15 through 40. So we could say, hey, what are the names of teams? We want the 15th through the 40th values, okay? So these are the names here. So we've got averages, and we've got these names, and we want these names to transpose, or to go copy over. So we're going to say take the names from teams, the 15th through 40th names in teams, and assign them to the names of the averages vector that we created. Okay, do we see that? Line 19, what that's doing? It's taking these names, and it's going to name this vector. So we're going to get what's called a named vector. And now, if we ask, what is averages? Okay, now that I've named the vector, when I ask for what is averages, each of those values has a little thing above it that tells you what it is, okay? It tells you, okay, 680 runs, 5,126 at-bats, 1,339 hits, 228 doubles, 45 triples, 105 home runs, so on and so forth. Yeah, question?
Why is it averages I minus 14?
Yeah, why is it I minus 14? Okay, well, where did I start? I started at 15 because we wanted from the 15th column, right? And we said the 15th column, 16th column, 17th column. Now, what would happen if I didn't do I minus 14? The very first value would get stored in the ith position, which would be the 15th position, okay? So I'd have like 14 NAs, and then the 15th value would be there. That's fine, but, and then we could clean it up later. But here we could just say, hey, offset it by 14, right? So other loops that we could do. So here's just another arbitrary loop, okay? So I could say x is going to be the vector 1 through 30. And then I'm going to create a vector called squared, which will just start off as being empty. And then I'm going to say for I in 1 through 30, we can say squared, store into position I, squared, and what we will do is we'll take the ith value of x and square it. Okay, now this is actually here. I don't even need to do that. All right, let's just do I squared. Okay, so this is just this. So I is going to start off at 1. It's going to go up through 30. And then we could say, hey, for each value, square I and store it into the ith position of squared. Okay? And then so if we ask what is squared, is going to start off in the first position. It gives us 1, then we get 4, 2 squared, 3 squared, 4 squared, 5 squared, so on and so forth. Okay, so we could do that. Here's just another arbitrary loop. All right, we'll start off with, how do you spell Fibonacci? All right, so we're going to just start off with 1, 1. For I in, we'll do 3 through 15. So starting in position 3, what do I want to do? For Fibonacci in position I, so the Fibonacci goes 1, 1, and then you add the 2 previous numbers to get the next one, right? So I would add 1 and 1 and get 2, and then the next number I would look at the 2 previous. I would look at 2 and 1 and get 3, and the next previous, what would I do? I would do 2 and 3 to get 5, 3 and 5 to get 8. So what should I do? So into position I, but Fibonacci position I, what 2 numbers am I adding?
I minus 1.
So I'm going to add Fibonacci position I minus 1 plus Fibonacci position what? I minus 2. Does that make sense? Okay, and so we're going to calculate values 50. Now, I need to have kind of 2 previous values, 1 and 1, or at least 0 and 1 or something. Okay, otherwise, so we'll start off with 2 numbers in Fibonacci, and that way we can calculate an I minus 1 through and an I minus 2. And then we do that, and then what are my Fibonacci numbers? Okay, now we can see the things grow, right? 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, so on and so forth. So these are just general for loops. And the truth is, we start you off introducing for loops, but then we immediately say, try not to use these things, okay? Try not to use these things. There's a lot of things. R is capable of a lot of kind of vectorized operations. So here, one of my earliest loops was go through the, one of these loops was take this number, 1, and square it and store it in position 1. Take 2, square it, store it in position 2. Take 3, square it, store it in position 3. Now, the truth is, you can also have just done is you could have just taken, hey, take the vector 1 through 30 and square it. And then you're going to get the same thing. Okay? And this is more efficient. Rather than building a loop, because computationally a loop is slow and expensive, meaning it takes your computer a long time to do it. Whereas this, we just say, hey, here's a vector, square it, and you get this. Okay? And this is what we call a vectorized operation. And R is really designed to do vectorized operations. It can do a lot of things. Not everything, okay? Later on, we might have to use if statements. If statements are not vectorized, so you got to be mindful of that. But that's what we have. Okay, let me give you your first view quiz answer. First view quiz answer is the letter E. E as in elephant. E as in elephant. All right. Is this okay for these kind of just basics of loop building? Right. I'll assign a couple. You'll get a chapter in data camp where you build some loops. Okay. Just for some extra exposure. Okay. There it is. Let's say we wanted to do something similar, right? We say, all right, we built the loop, we went through the teams columns, and we basically looked at all of these columns, and we said which ones, runs, at-bats, hits, doubles, triples, etc. And we took the average of these things, okay? Or the mean. There is a function in R that says, you know what? What if I just said summarize? And if I did summarize the old-fashioned way, what would I have to do? Right? So summarize with dplyr manual would be, we would do something like teams, and we would do summarize, and I would have to do something like mean underscore R is going to be mean R na.rm equals true. Okay, and then I would say like mean at bats is going to equal mean of the at bats column na.rm equals true, or something like that, right? Etc., etc., etc. And this would get kind of tedious to have to do for everything, okay? So what we can do is we could say, hey, you know what? Do summarize. I want you to apply the function mean. I also want you to use this option, na.rm equals true. Now notice, na.rm equals true is outside of mean. And mean, I'm not even using parentheses. I'm just referring to the name of the function. I'm saying, hey, this is the name of the function, mean here. And then, but we're saying, hey, do it. Let's do the second one first. Okay? And I'm going to say, hey, do this, apply this function across all of these columns. Okay? So I could say across the column year ID, across the columns runs through SF. Maybe I could just do, what was the, let's do R through FP, okay? We'll just do that, okay? And I can just say, hey, do it across these columns. Okay? And it does it, all right? It takes, and it gives me the mean runs, the mean at-bat, the mean hits and things. And it also just does other columns, like year ID or whatever, right? Because I gave it to that. So basically, we're just doing the same thing multiple different ways. So one way was we said, hey, build the for loop, go through each of these columns, and then add back the names of the columns. This is what we got. Okay, and now I said, try to avoid loops. Okay, right after I teach you a loop, I'm like, try to avoid this thing that I just taught you. All right. And we're saying we can use this function across, okay? And we can say, hey, do this thing, take the mean function, and apply it across these columns, okay? And so when you look at the results, we're getting, the same numbers. dplyr does a little bit of nice rounding for us, so the output is compact. And here, I specify year ID. I gave it another name, but pretty much we're getting the same output here and here, okay? Here, no loop. We just said do it across those things. Okay. You can also, so is this notation okay? Just saying like year ID and then starting at row column, keep going until you go to FP column. What is FP? Fielding percentage. Okay. And double plays and stuff like that. Okay. There's another thing. We can also say, hey, try I'm missing a closing parentheses here. This line's gonna error out. Did I? Oh wait, across. Oh no, I'm not missing anything. I'm sorry. Okay, so there is where is numeric? okay, is.numeric. So basically, we can take all of the columns in teams, and we can ask which columns are numeric, okay? So which columns are numeric? So if again, if we looked at the glimpse on teams, okay, so some of these columns, so if we look at the structure of this teams table, some columns are numeric, integers, double would be a number with a decimal. These are numeric columns. And then some are factors or characters, okay? So we have, you know, we can't ask what is the mean of BLC and ECK or something like that, right? There's no, you can't take the mean of these character things. So we just say, hey, which columns are numeric, okay? Is the column numeric? If so, apply this function mean, right? So we could, so which columns to run it across, you can give it a few things, right? So we could say do teams, do it across these columns here, okay? And so it's gonna do a few things that, you know, we didn't do in the other ones, like the number of wins or losses, that's fine. Games at home, runs, and things like that, okay? So the average games per season is around 150. Again, the basic season is 162. I'm sure the median, and if instead of mean, if I did the median, I guess it's not 162, it's 158, okay? And we're getting, now we don't have really any decimals when we do the medians. Okay. So there you have. There you have it, okay? For the entire table. The median number of home runs, 109, median number of hits, median number of at-bats. Okay, so that's using the across, okay? There's another function, okay? Kind of, and the structure is kind of like this, where we're doing across, but we can kind of pipe functions into it, okay? And so here, what is the result of this first part? If I do teams select 15 through 40, what am I going to get? Oh, let me give you your second view quiz answer. B. B as in bear. B as in bear, or baseball. Second view quiz answer, okay? So here, I do teams, select 15 through 40. We're just going to select the 15th through 40th columns in teams, okay? So we get columns 15 through 40. Maybe I'll spread this out a little bit. So here I'm just saying, hey, let me see these, okay? Columns 15 through 40, okay? Now what we can do is we can use the map function, all right? Map underscore double is just say, hey, I want to make sure the output of this is a number with decimals, okay? Is a type double number. But you could just use the generic thing, and you can map, you can just say, hey, I want you to apply this function. I want you to apply the function mean to all of these columns, okay? And again, notice that this is a different structure. Like when you created this, when you used summarize in dplyr, normally you have to give it a definition. You'd say, I want the mean of this column, right? I want the mean of this column, and you actually have to specify which column you're talking about. Here we can just say, hey, take the name of the function mean and map it across these things. Also give it the option na.rm equals true, okay? and we get something similar, right? So these are all just different ways for us to kind of get the same results. Different ways for us to get the same results. Okay? Just showing you how to do these kind of iterative operations where you have to, and the iterative thing that we're trying to achieve is calculate the mean of a whole bunch of different columns without having to say, I want the mean of this column, I want the mean of this column, I want the mean of this column, and having to repeat ourselves so many times, right? We want to be able to think of a little bit of a more efficient way to do something like this. And so there's lots of, so we can do that. There, you can, if you tried to apply this thing to something, someplace where it doesn't make sense, okay? So the example, to say team name, team ID. So just so you can see what team ID looks like, if I do that, team ID is basically a 3-digit code indicating, all right, oh, we're talking about Cincinnati or Detroit or Cleveland or something like that. Okay, we can't calculate the mean here. So if I said, hey, map the mean function there, it says, I don't know, okay? It gives us an NA. It tells us NA. Right, it says, this thing is not numeric or logical. If you gave it a vector of true and false values, it can give you an average. It would give you a decimal percentage of what's true, but you would give it some characters, a factor. It says it doesn't know how to do that. Okay. This is an interesting thing, right? So the Angels, the Los Angeles Angels of Anaheim, okay, is has gone through different names, okay? So tell me, what will this, we're not using any iterative things here, okay? So the franchise ID, all right? So there's a difference between franchise ID and team ID, okay? Because the franchise is the organization. And an organization can change names. It could even move cities, but it's the same franchise. So like when we talk about the Lakers, the franchise has a history of being in Minneapolis, right? So when we talk about how many championships has the Lakers won, we talk about the championships that were won in Los Angeles plus the championships that were won in Minneapolis, right? I don't know if you guys are familiar with, say, something like basketball. And sometimes teams will move, right? You have the Raiders as a football team, and it's moved all over the place. It was in Oakland, it was in Los Angeles, it went back to Oakland, now it's in Vegas, okay? That's the same franchise. So the franchise ID remains the same throughout its entire history. But the team ID, which is just a code, and the name changes, right? So you have it would be the Oakland Raiders becomes the Los Angeles Raiders or the Las Vegas Raiders. That team ID changes, okay? And basically the Angels, their name has changed from the Anaheim Angels to the Los Angeles Angels of Anaheim, to, I don't know, from like California Angels. So we're gonna say, hey, filter, I just wanna see this franchise ANA, right? The Angels, no matter what its name was. We're going to group by its team ID and name, which would be basically when it changed names. And then what is this? There's some clues in the column names. We're saying summarize after you group by team name, we want the smallest value for year ID, and the largest value for year ID. All right, and then we're going to arrange it by began. So this is what we end up getting. Okay, we have the Los Angeles Angels, which went from 1961 to 1964. They became the California Angels from 1965 to 1996. And then they became the Anaheim Angels, 1997 to 2004. And then they were the Los Angeles Angels. Now they are known as the Los Angeles Angels of Anaheim from 2005 to 2020. Okay? And so their team ID or their name has kind of changed. Is this okay? What's happening here? All right. What we can do is we could just extract this thing, right? We can extract the column. I can just do Angels $name, and I can extract that column. Okay. Sometimes you want to just get the name out, but you want it as part of like a series of pipes, or so you get just sometimes you want a certain column. So can you pipe it into the $ function? Yeah, it doesn't like that. Okay, so if you're like, I just want to get it doesn't like when you try to pipe the it might, let me see, it might work this way. Okay, so you could pipe it into the $ function, okay, but it's probably easier just to use the function pull. Okay, so you can use $name to extract the name column. You can also you can pipe it into pull name, and it will pull out that column, if that's all right. Okay, and then so now Angel's name is just this column: Los Angeles Angels, California Angels, Anaheim Angels, Los Angeles Angels of Anaheim. And we could say, how many characters are in this, right? So you've seen nchar already in your homework, number of characters in the name. So you can say, okay, the number of characters in Los Angeles Angels is 18 characters. Number of characters in the California Angels is 17. Number of characters in the Anaheim Angels is only 14. Or in the Los Angeles Angels of Anaheim, there's now 29 characters in their name, right? If you write out the full name. Here's that thing, okay? We could also just run the map function, okay? And the map function just says, hey, take this function, n characters, and apply it to everything in here, okay? And it will say, all right, you've got 4 elements in there. When I apply that number of characters functions to that thing, we get 18, 17, 14, and 29, okay? So rather than having to iterate through character 1, item 1, item 2, item 3, item 4, we can do this. Okay, it seems I am out of time. So we will end here for now with just kind of this little brief introduction on number of characters. Yeah. Oh, final quiz answer is A. A as in Apple, or Angels of Anaheim. All right, the letter A is your last view quiz answer. All right, have a good weekend, you guys. We will see you on Monday.